Letter B. Find the magnitude and direction of the instantaneous velocity at 0 second, 1 second, and 2 seconds. Okay, so earlier we calculated for the average velocity between 0 to 2. This time it's instantaneous velocity and then magnitude and direction. So how do we do this? We go back to our position as a function of time. Ito siya. Please allow me to drop the units first. Okay? Kaya dinrap ko na siya kasi medyo samok siya sa solution. Ilalagay na lang natin yung final unit sa final answer natin. Okay? So, but you can do that naman. Okay? So, what's our definition of instantaneous velocity? Balik tayo doon. We start with that. Okay? So, instantaneous velocity as a function of time. Again, I am not writing the subscript x here because I'm talking about the whole velocity vectors which can have 2 to 3 dimensions. Okay? Kaya walang x dito. Dito natin makikita si vx, vy. Okay, so balik ulit. We know that instantaneous velocity is the time derivative of position. So we'd say here that the time derivative of position as a function of time will give us the instantaneous velocity. So we'll just plug in the whole expression here to get the derivative. Okay? So r as a function of time, it's just 4 plus 2.5 t squared. This is the entire r position. Okay? Plus, I'm sorry, lagyan ko muna ng bracket kasi mas may sumpay pa siya dire. And then you have 5 t, j, and then the curly brace here. Okay? By the way, this time derivative of our position can also be broken down in terms of this. So, the time derivative of x as a function of time plus the time derivative of y position as a function of time plus the time derivative of the z position in terms of time. In this case, we only have a 2-dimensional position, so this one is 0. Okay? Ayan. So, parang binroken down ito. Kasi si d dt, isa-isahin mo yan dyan sa x and y component. Okay? Then, power rule lang tayo. Okay. So, derivative of constant is 0. So, ito siya magiging 5t. 5t I hat. And this one will become, correct, 5 na lang. 5j. So, let's take a look at the physical meaning of this. We now have the general expression of velocity at any time that we like. Take a look. The y component changes with time. I mean, the x component changes with time because of t here. However, the y component of the velocity remains at 5 centimeters per second. Meaning to say, yung bilis niya na along the positive y, hindi magbabago yan kahit anong time value ilalagay natin. It's the x component of the velocity here that changes. Okay? So, since meron na tayong velocity generator dito, you just plug in the specific numbers here and then makukuha na natin ang instantaneous velocity in component form. So, let's try v at time 0. So, instantaneous velocity when time is 0 is just 5, 0 I hat plus 5 j hat. Okay. So, velocity when time is 0, ito, wala siyang x component. So, ano lang siya along the y. So, pag start ng timer, yung dot natin is instantaneously going towards positive y. Yan yung sinasabi niya dito. So, this is 5 and then 2 significant figures. Ilalagay ko na ngayon si unit and then the j. Now, this can now be declared as the final answer. Okay? Kasi one-dimensional siya. Wala siyang x. So, the 5 centimeters already gives the magnitude of v when time is 0. And the j hat here gives the direction. So, okay na tayo sa mag and direction. Meaning to say, if the velocity turns out to be one-dimensional, then the final answer is already complete as long as you have the unit vector for the direction. Okay, and that goes positive j hat. Okay, so we're 1/3 done. We repeat the same process here for 1 and 2. Okay, so let me do this somewhere here. So velocity when time is 1 second this time, I'll go back to this expression. 5 times 1 I hat. Do not forget the unit vector ha, kasi these are vectors. And then 5j. So velocity instantaneous. Okay, in this case, pagpatak ng 1 second, pareho siya sa average velocity na na-solve natin kanina. So, this is 5.0 I hat plus 5.0 j hat. Since na-solve na natin to kanina, pwede ka namang magdiretso na lang, no? Declare ng final answer mo. So, velocity when time is 1 is equal to the average velocity. This is 7.1 centimeters per second and then 45 degrees for the direction. Okay, so that's velocity when time is 1. Magnitude, direction. Okay, now we go to the last part of part B. I'll use another color kay murag niluspad na ang akong ink. Okay, so I'll go velocity when time is 2 seconds this time. Go back here. 5 times 2 I hat plus 5 j hat. So we have 10 centimeters per second I hat plus 5 centimeters per second j hat. This is not yet the final answer because magnitude and direction man, this is component form. If you check, mas mabilis ang punta niya sa x kaysa pag-move niya sa y, no? Twice as fast kaysa sa y component niya. So, Pythagorean relation to determine the magnitude of v when time is 2. So, it's just 10 squared plus 5 squared. This is around 11.2. So, two significant figures, I'll just say it's 11 centimeters per second. And then for the direction, again, you have the components. I-sketch mo siya. Positive x, positive y. So, first quadrant ang bibigyan mo ng biggest space. Okay? So, for our velocity vector here, I'll go twice as long along the x. So, this is now velocity when time is 1 and then this is x component. Claro? And then half as long. This is instantaneous velocity when time is 1, but this is the y component. Starting point to end point. This is now our vector sum of these two, which is the velocity vector when time is 1 itself. And then I'll call this alpha for the direction. Okay? So, for the TOA ulit tayo, opposite over adjacent. So, alpha, you have arctan. Y is 5 over 10. And this is around, with two significant figures, si 26.6, I'll round it off to 27 degrees. Therefore, instantaneous velocity when time is 2 is 11 centimeters per second going towards 27 degrees. Standard position angle. So, that is how we solve for instantaneous velocities at different times if you're asked of magnitude and direction. Okay? So, if you look closer, as time goes by, si velocity ng dot, yung bilis ng dot as it goes in the screen, as it moves in the screen, it gets faster, no? It speeds up along the x-axis, but its y component is always 5. Okay? Sige.